Hello everybody, it's Mr. Hoffman here. I'm really excited for today's lesson. We're going to be subtracting decimals using a model drawing strategy. Our plan to achieve this goal is, first, I will review how to represent decimals with base 10 blocks. Then I will do 3 problem examples. After that, we will do some problems together, gradually releasing you to the you do assignment, your independent work. The you do assignment, your independent work, each of you will be assigned 2 different problems. You will record yourself completing both problems, explaining verbally out loud each step. Both problems in one recording, that is a total of 2 minutes or less. Bonus, post your recording on New Row and watch and comment on posts from 3 other classmates. Representing decimals with our base 10 blocks, we're going to be using the flat, the long, and the unit. I'm going to be showing this in the context of your place value chart because we will be moving into using a place value strategy to subtract decimals right after this lesson. So let's put it in the context. We have our unit is 1 cube, our long is 10 cubes all attached together, and then our flat, of course, for hundreds is 100 units. So unit is ones, long is tens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there are 100 little cubes here. Just for a quick review, how many longs fit in a flat? So in other words, let's take a look here. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 tens, which makes sense. 10 times 10 is 100. So when we extend over to the right of the decimal, we're going to reassign the values of these, the flat, the long, and the unit. So we're not going to use the unit as a 1 anymore. Instead, we're going to put the flat there. So now, instead of each little cube, each unit inside of here representing a 1, it's going to represent less than 1. Since there's 100 of them, each one is 1/100th. So that's where our unit's going to go. We'll get there in a few moments, but let's go to the long next. So where would the long go? Well, the only place left is the tenths. So that makes sense because how many longs, again, fit in a flat? 1, 2, 3, 4, 5, 6, 9, 10. So if we take one of those, which would be 1/10 of 1, that makes sense. 1/10. Slide it right over here. And then we'll take how many units fit in here? 1/10 of that. Just as kind of take off that long. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 units to make a long. So 1/10 of a long is 100th. And so there we go. We have, instead of the flat being hundreds, long being tens, and unit being ones, we're going to have flat be ones, long be tenths, and unit be hundredths. So far I reviewed how to represent decimals with base 10 blocks. Now we're going to get into the actual subtracting using those representations. I will do 3 problems. Here's the first one. Starting with 84 hundredths, subtract 56 hundredths. Here's a little reminder, again, of how we're representing these decimals. Starting with our ones. How many ones do we have? We have 0 ones. So we're not using the flat quite yet. And then we have our decimals separating our whole numbers from our fractions. Then we have 8/10. So we need 8 longs. 1, 2, 3, 7, 8. Now let's go to our hundredths. We need 4 hundredths. That means we need 4 units. Let's lay them down. 2, 3, 4. Now we're going to subtract. Now we're going to start subtracting with the digit that is furthest to the right of our decimal. In this case, it's a 6. And 6 what though? 6 hundredths. So let's subtract 6 hundredths. 1. There we go. 1, 2, 3, 4. Moving a little slow here. I'm getting ahead of myself. There we go, 4. Now we ran out of hundredths to subtract. And as you see, I kind of jumped ahead a little bit here. You're probably thinking, oh yeah, let's take them from this long. Let's do that. Let's break this long down. There are 10 of those there. So let's regroup them, borrow. And let's see, we got 4. And then let's subtract 5, 6. And we're left with 2, 4, 6, 7, 8 hundredths. Let's go to the tenths next. We need to subtract 5 tenths. 1, 2, 3, 4, 5. We're left with 2 tenths. And We got our decimal and 0 ones. So what are we left with? 2 tenths and how many hundredths? 8 hundredths. Let's put that together. That would be a total of 28 hundredths. There's 10 hundredths, 20 hundredths, and then 8 hundredths. In decimal form, that's 0.28. So we're going to do our second example now, subtracting decimals with our model. And we're going to move slightly more abstract. So instead of the straight up flat like this with all the little units indicated in here, 100 of them, we're just going to draw a square. And you have to imagine that there's 100 little units inside of here, which would also be equivalent to 10 longs inside of here. But for our long, we're going to go more two-dimensional again. And so we're moving from 3-dimension to 2-dimension. And you have to imagine that there's 10 units inside of here. And then our unit, instead of a 3-dimensional cube, is going to just be a square. All right, let's use that representation to do this problem. 2 ones. Decimal separating our fraction from our whole numbers. 3 tenths. There's 1, 2, 3 tenths. We have 4 hundredths. Now we can start subtracting. Remember, we're going to go furthest to the digit furthest to the right of the decimal. So that is 5. 5 what? 5 hundredths. So let's subtract 5 hundredths. 1, 2, 3, 4, and we ran out. So as previously said, we're going to regroup, borrow from one of these tenths here. There are 10 hundredths and 1 tenth. So let's lay them down. 9, 10. And so we've taken away 4. We need to subtract a total of 5. Take away 1 more. There it is. We've already used this, so make sure you cross that off so we don't use it again by accident. And let's go on, continue to our tenths. 7 tenths. Oh, right away I can see I don't have enough tenths. So I'm going to borrow first this time from my whole number here. And how many tenths are in here? You have to imagine there are 10 in there. And oops, I don't know what happened here. Close. Here we go. 2. There we go. And then cross that off so we don't mistakenly use that again later. And let's go ahead and subtract our 7 tenths. 1, 2, 3, 4 tenths, 5 tenths, 6 tenths, 7 tenths. We're left with 5 tenths. We're not done yet. We still see our decimal separating our fraction from whole number. And we have our ones. We have to subtract 1 more 1. That leaves us with 0 ones. Now we can go ahead and lay down our answer. How many hundredths are left? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many tenths are left? 5. Remember the decimal, very important, separating our fraction from our whole number. How many ones? Well, we've subtracted 1 and we regrouped 1, so we don't have any ones left. So really quick there. Let's just take a quick look back. We're not going back here. There we go. So our answer is 59 hundredths. Now we go to this next screen. So we've reviewed how to represent decimals with base 10 blocks. I did 2 problems. Going to do 1 more, but we're going to switch from this PowerPoint to writing stuff down. So hopefully you got your pencil and paper ready. We're going to be doing just a quick note on that as well. We're going to do a few problems together. I'm going to do 1 more. And I write, you write. Then you will be gradually released to your assignment as we become mastering. Okay, so I write, you write. First thing is our title, subtracting decimals with model. This little line above the W is shorthand for with, the word with. So far, we've used the base 10, more 3-dimensional with all the little nuances here indicated, every little unit indicated. And then we kind of gradually moving into here, 2-dimensional without everything indicated. And then now we're going to go full gorilla for doing our drawing model, where our flat is really the same. Our long, instead of a 2-dimension, we're going to go more 1-dimensional here, just a straight line. Imagining again that these are made of 10 units. And then our unit, instead of a square, now we're going to just go a little dot. So it's a little bit easier to draw that way. Let's label that really quick. 1, whole. This is 1/10 or 0.1. This is 1/100th or 0.01. Okay, one more I do problem. 0.62, 62 hundredths minus 0.18, 18 hundredths. Beginning with the 6. The 6 is in our 10th place, so we need 6/10ths. We need 6 longs. 1, 2, 3, 4, 5, 6. And then we need 2, where did the 6? We need 2 hundredths. It's in the hundredths place. So we need 2 of these dots. 1, 2. Let's go ahead and begin subtracting. Furthest to the right, we're going to start with our 8 here. And 8 is in the hundredths place. So we need 8. We need to subtract 8 dots. 1, 2. Oh, ran out of dots. Let's borrow from here. Regroup. 1 long equals 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've already subtracted 2. We need to subtract a total of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Done. Let's move on to our 10th place. We need to subtract 1/10. Now remember, we've already used this 10th. So let's subtract this 10th. Done. Now we can go ahead and write our answer. We have 1, 2, 3, 4, 4 hundredths left. We have 1, 2, 3, 4, 4 tenths left. Remember the decimal separating our fraction from our whole number, and we don't have any whole numbers left, 0 ones. So 44 hundredths is our answer. Okay, that's the end of the I do. At this point, we would go to the we do, and I would have students tell me what to draw. I would try to elicit interaction from the students who are non-Delta students here, anticipating that these particular students here would be mastering this material quicker, and I would be releasing them sooner to do their independent work, while I would remain working with probably these students and whatever students are still needing to have remediation. And we would go back and forth from doing another we do, and then I would I would give them a quick formative assessment and to see when they're ready to be released. So probably right away, even after just doing, I would say, two or three of these problems as a we do, I would go, okay, everybody, get your pencil ready, get your paper ready, or you can do it on a whiteboard if you have your whiteboard and your whiteboard dry erase marker and so on. And here's your problem. And they would do it independently by themselves when no one else would see. And then you have 2 minutes. Then I would have them lift up their answers, and I would check and say, okay, you're good to go. You can go to the independent assignment. You can go, okay, I want you to stay here with me. You stay with me for another problem, do another we do, and then go to, say, let's get you on here. And then do another quick formative assessment until all students have reached that mastery level, at least for the moment mastery level. And then that would be it. By the way, I would also be providing an encouragement, feedback, and support, hopefully helping them, guiding them to kind of correct their own mistakes and kind of detect their own mistakes if possible. Then I thought as an ELL accommodation, when they do their independent assignment, that they could record in their own language. For virtual independent work, I thought that this seemed to be lending itself more to them kind of doing a more of explaining and speaking out loud what they're doing. That I think is very effective and very popular with the students that I've worked with during the pandemic. When made that assignment, kids really enjoyed that. But they also really enjoyed the quizzes that I made on Yakapaka and Kahoot. So I really like Yakapaka, for example, because it allows me to tailor the questions and quizzes to the specific needs that I can see where students are really struggling with, obstacles and challenges that they're trying to overcome for any given topic or area. And so I could just get creative with that and really customize it. And it provides me and the students with immediate feedback. It allows like a level. So I can just do a few questions on one thing to help them get to a point, and they can do it over and over until they get mastery at that level. So it's like, oh, how many lives do you have? Infinity. So they do that. Then they feel really confident. They go on to the next level, and the next level, and I can level these things up. And so it gets kind of addictive in a really good way. And let's see, resources. I would link the PowerPoint that I did to something they could access, Blackboard, Miro, Canvas, what it may be. Also, I'll link an anchor chart providing more of the drawing part that we did here. So it's a little bit easier for them to access and refer to. And I would probably link some YouTube videos on how to record their own lesson that they're going to be doing for the independent assignment. All right. Thank you very much. Bye-bye.